to jump into 5.5 section example 3, and we have yet another theorem to add to our electronic notebook. So I did want to point that out, the triangle inequality theorem, and I'll go over that in just a second. If you look up here at the figure, what I'm trying to impress upon you is just because you're given 3 side lengths for a triangle, that doesn't mean it actually forms a triangle, okay? And so, you know, the first one here that has side lengths of 4, 4, and 7, that's going to form a triangle, but the one that has side lengths of 3, 3, and 7 does not. The 3's are not long enough to touch each other and actually meet and form a triangle. And so there is a way to figure out if the side lengths of a triangle actually form a triangle. There's a way to figure it out, and it's called the triangle inequality theorem. And this is what it says. The sum of any 2 side lengths of a triangle is greater than the third side. So whatever 2 you're looking at, they should be greater than the third side, okay? And you're going to have 3 pairings. So here's the first one right here. AB, which is right here, plus BC. Those 2 sides should be bigger than AC. Okay, so that's one statement. Let's look at the next one. BC and AC, those 2 together should be bigger than AB. And then here's the last one. AC and AB should be bigger than the one that's not been included, which is BC. So that's what the whole deal with the triangle inequality theorem is. You can create an inequality with known side lengths and then see if numerically it works out, okay? So any 2 sides of a triangle should be bigger than the third one, okay? You should have 3 statements you can write from each of these. Let's flip the page and let's tackle example 3 and apply this triangle inequality theorem. You've been given 3 side lengths, and we have to prove that it's a triangle, okay? So 3, 5, and 7. So this is what we have to do. Here's our first statement. 3 plus 5 is greater than 7. 5 plus 7 is greater than 3. 3 plus 7 is greater than 5. So I took the first side plus the second side. Is that bigger than the third side? Then I did the second side and the third side. Is that bigger than the first side? And then I did first and third. Is that bigger than the second side? All right, so let's let the numbers tell us what the story is. Is 8 bigger than 7? Yes. Is 12 bigger than 3? Yes. Is 10 bigger than 5? Yes. Then we have a triangle. Okay? 3, 5, and 7 form a triangle. It works. Okay? Let's look at letter B. So we've got 4 plus 6.5 is bigger than 11. 6.5 plus 11 is bigger than 4. 4 plus 11 is bigger than 6.5. Okay, so I did first angle plus second angle. Is that bigger than the third angle? Is the second angle plus the third angle bigger than the first one? Is the first one and the third one bigger than the second one, the second side length, okay? So 4 plus 6.5, this is where you let the numbers kind of drive this answer. 4 plus 6.5 is only 10.5. Is 10.5 bigger than 11? No. Then this is not a triangle. I don't need to know the other 2, whether the other 2 work out or not. If they all work out, then it's a triangle. If only one of them doesn't work, it's not a triangle. You don't even need to worry about the next 2. Who cares? Who cares? The first one didn't work. It's not a triangle. Okay, letter C, they told us what to plug in here. So first thing we're going to do is we've got to figure out the side lengths. So if n is 3, 3 plus 5 is 8, 3 squared is 9, and 2 times 3 is 6. So there's our side lengths. And then we're going to do the same thing. 8 plus 9, is that bigger than 6? Is 9 plus 6 bigger than 8? Is 8 plus 6 bigger than 9? And so we've got 17 is bigger than 6. Yes, it is. 15 is bigger than 8. Yes, it is. 14 is bigger than 9. Yes, it is. We have a triangle. Okay? So that's how you do it, guys. So I'm going to give you 3 points, one for each of these, and you need to prove that these are triangles, or whether it is a triangle or is not a triangle. And your explanation, the way you explain this, is the numbers are going to derive this answer. So that's what I'm looking for, are the numbers. The proof is in the numbers. Okay? So bring your questions to class.